Okay, this stream will start very soon. Let's wait for a couple of more people joining, actually. Cool. Let me quickly switch the screen. All right, so I see some of people are joining. Others could join soon or watch video maybe later. Today I guess we're gonna mostly check for two less known vulnerabilities, two less known client-side vulnerabilities. So it will be prototype pollution and DOM clobbering. About DOM clobbering, I haven't actually know this type of vulnerability. I have heard a little bit about prototype pollution. So I guess we're gonna learn together something new as well. I know those vulnerabilities do exist and not a lot of people know about those. So it will be really interesting if we could learn something new. So yeah, let's deep dive into this journey with me. If you are following every stream, even if you are just watching it later on YouTube, you're a true hero, because I think this back to school challenge is pretty intense, because like streaming every day takes a lot of time. Not every people have that much amount of dedication, but still, let's continue and let's do it. So we're gonna continue on the series called Beyond XSS. This time it will be the vulnerability is different from XSS and maybe less often occurring in the wild, but those definitely do exist, but they're not exploited that much, since this is not really that common one. So yeah, all right, let's explore this first article. It's not like about any of that vulnerability, but it will be just an introduction into chapter 3. So who says you have to execute the JavaScript directly to attack? Up to this point, the chapter 2 defense and bypass for XSS comes to a close. We have spent a lot of time discussing XSS, including various ways to execute XSS, defense techniques, and bypass methods. In terms of web frontend, the most serious thing that can be done to the web page is essentially executing the code. So yeah, we learned a lot of that. Actually, not only the 3 mostly known XSS vulnerabilities, but also some bit advanced ones, for example, universal XSS and like mutation XSS. So those are less known by many people, and those were like explored. And of course, defenses. You have to understand how defenses are put in place and then how you can bypass that defenses. So yeah, it was quite a journey, and let's go with some more vulns. All right. So in the examples of attacks, we basically assume that being able to inject HTML as a premise and then find ways to transform it into XSS. Although we have only used this simple payload with previous examples like this one, which with image tag, it may not be easy in the real world scenarios. Yeah, because there are a lot of defenses, especially if there is a program which is actually matured quite well. For example, we briefly mentioned earlier that there is another defense line called Web Application Firewall, which is the firewall specifically designed for applications. It uses pre-written rules to block seemingly malicious payloads. For instance, Dcard, a social media platform in Taiwan, uses Cloudflare Web Application Firewall. You can try clicking this link. I don't want to click it, but you will see the blocked message. Yeah, this is really like common image used by Cloudflare. The most well-known open source web application firewall is itsecurity, which provides an infrastructure for engineers to add their blocking rules or use ones written by others. For example, the OWASP itsecurity core rules set CRS is an open source collection of rules. Let's take a look in small section. Okay. Set rule, request cookies. Okay, let's maybe deep dive into explanation to be way faster. The rule uses regular expression script. Where it is actually? I don't. Oh, maybe no. Oh, I think right here. Okay. Regular expression to find the code containing script and blocks it. Therefore, the script alert will be detected and blocked. There are also other rules corresponding to our favorite image source X on error alert. So in practice, we often encounter situations where we think the website is easy to attack, but it turns out to be blocked by WAF. We keep seeing error windows even though the vulnerability exists, but we can't exploit because of the WAF. This cat and mouse game between hackers and websites is one interesting aspect of cybersecurity. It emphasizes the importance, experience, and the knowledge. Regarding to WAF, many WAF bypass payloads often appear on Twitter. Yeah, I do quite like when people like posting some crazy payloads. I guess we might explore that, but not maybe during this month, maybe a little bit later. I will like give some opinion as well. To bypass WAF, the content is usually intentionally disgusting, like this. Okay, like bakes bonbon or something. I know this user. So, okay, it uses detail tag. It escapes spaces just by using this character. It uses mixed cases. Open equals open, not sure what it is. href equals data, and it has on toggle alert document domain, and it's not closing that tag. So it's not very common payload. So if there is blacklist rules, some blacklist rules exist in place, this could be as a bypass for sure. Actually, the content this payload intends to execute details open on toggle alert document domain, but it uses bunch of other keywords to obfuscate it. Since many WAFs rely on regular expressions for detection, as long as the payload is not easily recognizable by WAF, it can be bypassed using this method. Yeah, but if there is web application firewalls with some like automated detection, it will be way harder. Try bypassing Akamai. Yeah, but what if it can be bypassed? Even if website can inject HTML, so what? If the payload that can execute XSS cannot be written, does that mean there is no solution? Not necessarily. Alright. This kind of thinking usually stems from limited understanding of front-end security, where XSS is only known attack. It is often believed that executing code directly is necessary to achieve an attack. In fact, there are many other indirect attack methods, and some attack examples do not even require executing JavaScript. Alright. As mentioned at the beginning of the series, the front-end security is a vast universe. We have already spent a lot of time exploring XSS, So it's time to enter a new galaxy. Let's take a short break, and in the next post we will officially enter chapter 3. No, I thought I am already in the chapter 3. Why are you scamming me? Okay, attacks without JavaScript. In the upcoming content, we'll introduce more attack techniques beyond XSS. The chapter 3 will progress step by step from indirectly influencing the execution of JavaScript to not only needing JavaScript at all, and even not just JavaScript but also without CSS. Alright, okay. We will continuously explore the limits of front-end attacks. Before entering chapter 3, okay, you can also think about attack techniques and don't execute JavaScript directly that you have heard of. It is very likely that they will be covered in the upcoming content. Finally, let's have a little quiz. Bob is implementing the multiplayer drawing game using two-dimensional array that represents canvas. Players can draw any color on the grid and the array is updated on message using onMessage handler. The implementation as follows. Okay, what is the problem with the code? We will reveal in the next post. onMessage is calling the function event. It will save into the free variables event data and paste this to the screen. Okay, we're gonna explore that in the upcoming article for sure. All right, it's cool. So let's go to the prototype evolution. This is pretty fresh vulnerability type. Let's explore this one. Okay, as a front-end engineer who deals with JavaScript every day, you might have heard about prototype chain, even if you don't directly use it in your work. Well, you're kind of assuming that all the people reading here are like JavaScript engineers. No, not necessarily. But alright. But did you know that prototype chain can be also used as a means of attack? Although it cannot directly execute JavaScript, it can indirectly affect many execution flows. By combining existing code, it's possible to create powerful vulnerabilities. Let's take a look at this technique and powerful vulnerability together. Okay, cool. Object-oriented programming in the JavaScript is different from other programming languages. The class syntax, as you see now, was introduced in ES6. Before that, the prototype was used for the same purpose, also known as prototype inheritance. Let's take an example. Have you ever wondered where built-in functions come from when you use them? Okay, so this is like string and this is inbuilt function. So it's actually just creating 5 A's, I think. Where does repeat function come from? Okay, you might even notice that repeat method of 2 different strings is actually the same function. Okay, so it will return the true, I guess. Even triple equal sign, so it also checks if it's Boolean and if the like this side and this side is true. Or if you ever checked MDN, you would find that the title is not repeat but string prototype repeat. Okay, the repeat method constructs and returns new string which contains specified number of copies of string which is called concatenated altogether. Okay, so it will just repeat same string over and over, like specified time, so like 5 times A concatenated. Okay, and all of this related to prototypes. When you call string repeat, there isn't actually a method called repeat on str instance. So how does the JavaScript engine work behind the scenes? Okay, let's go even deeper into the JavaScript itself. Do you remember the concept of the scope? If I use variable and it's not found in the local scope, the JavaScript engine will look in the next outer scope and so on until it reaches the global scope. It is called the scope chain. The JavaScript engine follows this chain to continuously search upwards until it reaches the top. The concept of prototype chain is exactly the same, but the difference is how does JavaScript engine know where to look next. If the JavaScript engine cannot find repeat function on str, where should I look? In JavaScript there is hidden property called proto, which stores the value of where JavaScript engine should look next. Oh, that's kind of interesting. If we can, I'm assuming if we can change where JavaScript looks next, we can try kind of exploit its the core functionality of JavaScript probably. But let's see. For example, if this str console log str proto string prototype, it will return string prototype. Okay, the thing that str proto points to the next level where JavaScript engine should look when it cannot find something on str variable, and this next level will be string prototype. Okay, this explains why MDN does not write repeat but write string prototype repeat, because this is full name of repeat function. This repeat function actually exists as the method on string prototype object. Okay, so I guess the repeat exists somewhere inside this object. If you don't know what I'm talking about, you have to know a little bit about object programming, like what is classes, what is objects. It's kind of core basics of programming, like object-oriented programming. I highly recommend checking that, and some basics of JavaScript as well, because some of you, if everything is new, this could be hard to understand for sure. Alright, the same applies to things other than strings, such as objects. Okay, so this looks like the variable of new object is being created, and if we try to access some kind of value of that empty object, it will return undefined. But if we try to access that object function, it will return this basically, like native code or something. Even though object is empty object, why does object to string exist? Because when JavaScript engine cannot find on object, it looks into object proto, and object proto points to object prototype. So the object to string ultimately finds object prototype to string. Okay, nice. So modifying the properties on the default prototype. The proto of the string prototype of the string is string prototype, the proto of the number is number prototype, and the proto of the array is array prototype. Yeah, so it's just basically saying which different objects of certain variables could be like translated basically. These associations are already predefined to allow these types to share same functions. If each string had its own repeat function, there would be million different repeat functions for million strings, even though they all do the same thing. That doesn't sound reasonable, right? So by using the prototype, we can place repeat in the string prototype, so every string that uses this function will call the same function. Okay. You might wonder how the function can differentiate between different strings and then they are called with same function and parameters. Okay, the answer is this. Let's take a look at an example. So this is the example. So this is the function. First, I added method called first. This is like newly added one to a string prototype. So when I call empty string first, the JavaScript engine looks up the string prototype through the proto and finds that string prototype first exists, so it calls this function. So yeah, this is like newly created one, and then he's calling this function. Okay, it's kind of interesting. Due to rules of this, when the this first is written, this inside first will be this. If ABC first is called, this inside first will be ABC. Therefore, we call this to verify what is calling it. Okay. The way string prototype first is written above directly modifies the prototype of string, adding the new method that can be used by all strings. Although it is convenient that this approach is not recommended in development, there is saying don't modify objects you do not own. For example, Moo Tools did something similar, which resulted in the change name for array method. You can find more details in my previous article. Okay. Furthermore, since string prototype can be modified, it's natural that object prototype can be also modified like this. So yeah, he's just basically creating into the object the new function and assigning the number for that function. Then it's creating the empty object and then calling that same object for that function he specified, and it is returning that number. All right. But I can't really wait how you can exploit that, but we are just learning how it works basically. All right, because object prototype has been modified when accessing object A, the JavaScript engine cannot find property A on object, so it looks up to object.proto, which is object prototype, and finds A there, returning a value. Yeah, so just basically explaining what's happening here. When a program has vulnerability that allows attackers to modify properties on the prototype chain, it's called a prototype pollution. Finally. Okay. Yeah, so basically you pollute objects or strings or numbers, their prototype, so you are just adding the custom function into that, and then you need to call that function to do some stuff for sure. When pollution implies a contamination, yeah, it's just another word of the pollution. In the example above, we polluted a property of object prototype but using project A, like assigning the number to the prototype, which led to unexpected behavior when accessing objects. So what are the consequences of this pollution? So the string of abc.first prints the index of string A. Okay, not sure what you're referring actually. Yeah, but basically before like assigning object, you can, if you pollute the prototype of the object itself by like custom function, like custom value, in this case this is just a value, then someone tries to access that object and like calls that custom function, you can like execute that function This is what's actually happening here. Okay, let's go. What can be done after polluting a property? Let's say there is search function on a website which retrieves the value q from the query string, and it displays on the screen like this. The search result for symmetrics. Okay, it's not showing much. The code of this functionality written as follows. Okay, it is variable, the new object, which is basically in the URL searches and slices it, and then it creates a new element on the document, on the page, like h2 tag, and then inside the h2 they will write search result for, and then they will call that variable and get the q parameter value basically. Okay, so there is create element function. It's basically just tries to create like new element. Yeah. Config, where is the config? Oh, I guess they are specifying the config here. Okay, let's maybe read it, we will save way more time, because usually he explains what's happening. The code above seems fine, right? We wrote function create element to simplify some steps and generate components based on the provided string. To prevent XSS, we used inner text instead of inner HTML. Yeah, this is actually the way to sanitize some payloads. So there should not be risk of XSS. It appears to be correct, but what if there is prototype pollution vulnerability before executing this code, but allowed an attacker to pollute properties of the prototype? For example, something like this. Okay, so it's polluting this function actually by the payload. All right, and then it's basically the same. Yeah, it's the same, but just polluting the prototype before calling everything. Only difference in the code above is addition to object prototype, like this, like the second line, because this is first, this is second line, yeah, at the beginning. So because this line is polluted inner HTML function, the condition if config inner HTML, this condition basically right here, evaluates to true, changing the behavior. Okay, so it will change the behavior. Originally inner text was used in the else function, but now it has changed to inner HTML, resulting into the XSS attack. Okay, that's interesting. This is an XSS attack caused by prototype pollution. In general, the prototype pollution refers to the vulnerabilities in a program that allows attackers to pollute properties on prototype chain. However, in addition to pollution, the attacker must find the place where it can have an impact in order to carry out the complete attack. At this point, you might be curious about what kind of code can have vulnerabilities, but allow attackers to modify properties on prototype chain. Okay. So yeah, how we can actually pollute the properties of the prototype. So how does prototype pollution occur? Okay, there are common scenarios where this kind of issue occurs. The first one is by parsing the query string. So I guess prototype pollutions, usually where they happen, usually they might happen in some search queries where the JavaScript is being used, probably. Okay, you might think that the query string like a equals 1, b equals 2 is straightforward, but in the reality many query string libraries support arrays such as this or even this that can be parsed as arrays. Apart from arrays, some libraries even support objects like this. Okay, even though everything happens in JavaScript. Okay, which results into the object. So for example, the QS library supports object parsing. If you are responsible for implementing this functionality, how you write it? We can start with basic version that only handles objects without considering URL encoding or arrays. So this is the main function, and imagine this is coming from the URL, and it will just use this function. It will parse this and save it to the variable, and that variable will become this. Like it will become the JavaScript object from this one. So basically it constructs an object based on the content inside here and assigns values layer by layer. It seems simple, but wait, if my query string looks like this, okay, things change. Okay, so if you're, instead of this, you in URL, for example, you write this. Yeah, you can poison as well, I guess, the prototype. So it will just write free. All right. Then query string is like this. Parse queues will modify value of object proto A, causing the prototype pollution. As a result, when later declare an empty object and print object A, it prints free because the object prototype has been polluted. Okay, I'm pretty curious how you can exploit it in the wild, because I don't think this would be really common vulnerability. You have to actually do a lot of JavaScript analysis to see the things like that, unless it could be automated in some way. And I think that a lot of people who will just see prototype pollution, they will just skip it because it is like a dark forest to them. It's unknown territory. And yeah, but once you know about this vulnerability, you can try exploiting it. So yeah, so I guess some automation and detection tools could help, like who are just parsing JavaScript could help a lot to detect this. Or you can do a lot of manual code analysis, but this will be really time consuming. Then the query string is like this. Will modify the value of this, causing prototype pollution. As the result, when I declare an empty object and print object A, it prints free because the object prototype has been polluted. Many query string parsing libraries have encountered similar issues. Here are a few examples. Okay, so yeah, some JavaScript libraries usually have that. So jQuery deparam, backbone of query parameters, jQuery query object has the prototype pollutions, I guess. Apart from parsing the query strings, another common scenario where this issue occurs in object merging. A simple object merging function looks like this. So the merge A and B, Jesus, it's really hard to read. I would prefer if those variables will have like this cat dog and something like that, and it will create cat dog, because just using letters, it's extremely hard to read. I don't like the obfuscated code. I will just skip that. In the custom config above is controllable, so the problems rise. Okay, custom config, This is, for example, user controllable. So yeah, if this becomes proto, we use JSON parse and directly writing this. For custom config will only be empty object. To create an object with the key of proto, we need to use JSON parse. Similarly, many merge related libraries have had this vulnerability. Here are a few examples. Okay, so basically those vulnerabilities usually exist in some kind of JavaScript libraries, and I think there is like very big attack surface, but you need to actually do source code analysis on JavaScript libraries, and then you, like with some static code analysis tools probably, and then you might find prototype pollution. But as well, like, you need to know where you can try to put payloads. Even though some websites are using certain libraries, it doesn't mean that there will be exact location where you can pollute parameters maybe. But yeah, it does require intense source code analysis. But if you're working on some STR program, maybe it's worth trying to do this. Or you are just a giga nerd and like to read source code as the hobby, then yeah. Okay, besides these, almost any library that operates on objects had encountered similar issues, such as Immer, MooTools, Redis. The quiz I presented at the end of previous article also a vulnerable area. Okay, so this is the quiz provided on previous article. So if the attacker, instead of, I guess, this, will provide this, it will resort into the prototype pollution, like polluting object prototype with test function. Therefore, for values passed by users, it's crucial to perform validation. Now, what we need to know where prototype pollution issues can occur. It's not enough to just pollute the properties on the prototype. We just need to identify areas that can be polluted, meaning the places where behavior changes, the properties are polluted. This is allowed to execute attacks. Yeah, what I was just concerned about that. Yeah, you can do that for sure if there is a weak code, but where you can do that? So yeah, this like was the question popping in my head actually while I was reading this. Okay, prototype pollution script gadgets. These code snippets that are exploited if we pollute the prototype are called script gadgets. There is a GitHub repository dedicated to collecting these gadgets, client-side prototype pollution. Some of those gadgets may be unimaginable. Let me demonstrate. Okay, script gadgets. Let's see. So this is just like HTML, uses Vue.js. This is the app, and on the app there is a message, and inside the script tag there is object prototype template. I guess this is the area where user could inject something probably, and it sends data to the message. Okay, the seemingly harmless Vue hello world code, but after polluting, like right here, it becomes an XSS vulnerability that allows us to inject an arbitrary code, or like this. So yeah, it becomes this basically. This is a library that is supposed to sanitize input, but after the polluting object prototype inner text, it becomes helpful tool for XSS attacks. Yeah, if you can pollute certain function, but it's meant for protecting from XSS. If you can pollute that with XSS, it's crazy. It's crazy. Damn. But how the user is polluting that, I'm not actually getting, because on this code example, you're not getting data from the user. I know author is not using the best examples probably, because you need to get data from the user. Right here is just pasting that to the code. I would like if he could update this a little bit, but I understand he basically was writing one article per day, so it's extremely intensive work. It's not like me, I'm just reviewing the articles every day. All right. So yeah, it becomes polluted with XSS. It's crazy. Why do these issues occur? Taking an example of sanitize HTML because of this piece of code. Since inner text is assumed to be safe string by default, it's directly concatenated. And then we pollute this property. If the property does not exist, the value of the prototype will be used, resulting in XSS. In addition to client-side vulnerabilities, there are similar risks on the server side. For example, this. Okay, yeah, we can even target the server side. That's crazy. Because yeah, right now, these days you can use JavaScript on the server side even. There are frameworks like Node.js. So that's kind of crazy days we are actually living in. It's not new thing, but yeah, it's kind of crazy where you can use JavaScript everywhere. In addition to client side, okay, so child process require child process params spawn sync std out. Okay, this is simple piece of code that executes echo command and passes into the parameter, in a parameter. The parameter is automatically processed, so there is no need to worry about command injection. Okay, params, echo params. However, if there is a prototype pollution vulnerability, you can transform into RCE. Oh, okay. That's crazy. Okay, allowing attackers to execute arbitrary commands, assuming the attacker can control the params. Yeah, if, for example, assuming this is coming from the attacker, if you can pollute it right here, this, okay, it's actually returning spawn scene, child process, params. Okay, the reason for that is that the third parameter options, like I think this one, of child process spawn, no wait, child process spawn, is option called shell, which when it's set to true causes the different behavior. Yeah, I think he forgot to add spawn sync or something, so it actually has one more parameter which actually converted the default is false, but he polluted this parameter. So instead of not executing shell, right now the JavaScript is executing the shell. This is crazy. But what I want to see is real world examples, like seriously the reports maybe, or something like that. That could be interesting as well, because right now this is only the theory. I'm really interested in this. I probably maybe on the next stream we will try to skip like reading more, and maybe I gonna select some of the write-ups where actually on the real world that actually happened, like prototype pollution, because this is theory. Like knowing the theory is good because you will understand the write-up itself easier this way. But like what basically is happening, the attacker is polluting the object prototype with some custom function or existing function. In this case, this was an existing function, and it was like creating, like instead of default false, it created a true. In that case, the spawn sync function was actually executing the code on the backend. So that's crazy. Okay. Then combining prototype pollution with script gadgets, child process spawn is highly critical vulnerability is created. Yeah, for sure, this is critical. Okay, mid summary. Oh, we haven't even completed the mid of this. All right. If there is a functionality in program that allows attackers to pollute properties on the prototype, this vulnerability is called prototype pollution. Prototype pollution itself is not very useful and needs to be combined with other code to be effective. And the code can be combined with, it is called the script gadgets. For example, Vue's internal implementation renders something based on the template property of the object by polluting the prototype template. We can create an XSS vulnerability, or in the case of child process spawn, it uses shell, so after polluting it, it becomes RC vulnerability. The fix is not actually the script gadgets that can be exploited unless you can change every place where the values of objects are accessed, but this is not a fundamental solution. The real solution is to prevent prototypes pollution and ensure that prototype is not polluted, thereby eliminating these issues. Okay, how people are defending against this? On any prototype pollution vulnerability page on Snyk, there are defense recommendations. You can also refer to this article. Okay. So Node.js, this I guess gonna be interesting. This is like a research paper. Oh Jesus, this is 27 pages. Yeah, I'm not gonna read this for the stream. I could spend whole day reading this, so maybe next time. Okay. There are several common defense methods. First one is to block proto key when performing operations on these objects. So I guess maybe using some code or like firewall to block this keyword. For example, previously mentioned parsing of query strings, merging objects can adopt this approach. However, besides the proto, another bypass method could be noted. Okay, not only blocking proto, but constructor prototype. And then, yeah, this is another way to do it. I wonder if there is a word list for that. Let me quickly check the GitHub. Pollution. Word list. Just for fuzzing, I'm pretty interested. Maybe let's check hack tricks and also payload all the things. Let's see if there are some. Okay, Node.js. This is extremely simplified because I think that's what's happened in this research paper, but it's simplified. I actually prefer this type of read. Okay, but what I was looking was actually how how you should test for that. So labs, there are the labs. Oh, Portsvigger has prototype pollution. That's kind of interesting. I might try this one as well on some streams. Yeah, finally, this example is way better. He's not just using letters like A, B, he's using dog. I really like that like objects have names, not like minimized versions. Okay, examples. Yeah, he's just basically poisoning his admin prototype. Okay, manual testing, Express.js, reflected JSON input. So you can paste this in the JSON and see if something could be polluted. Asynchronous payload for Node.js, shell node. Okay, so I guess it could be really dangerous when in the backend the Node.js is being used, because it uses JavaScript, and if you can pollute JavaScript in the server side, it's gonna be crazy. You can compromise server probably. Okay, yeah, via URL. Other thing what is also pretty interesting for me, is there any nuclei template for this? Just in case if you want to automate it. Let's see if nuclei templates. I'm gonna explore the code a little bit. Let's see, prototype maybe, and then do another grep pollution. Oh, come on, it's hard to read. It's very hard to read. Headless prototype pollution check. Yeah, I guess there is, but you need to use headless mode for that, and the for request is being made. So it's basically just checking the URL, and it's doing some kind of browser automation and sees if this word is appearing. Other is trying other type of prototype pollution. Constructor prototype vulnerable prop. Okay, polluted. Okay, so there is actually there is a template for checking that, but I guess if you want to be extreme, hello, thank you for joining. If you want to be a little bit advanced, you might want to modify that template, but I think it's gonna take way like really long time, because it uses headless mode, so it's consuming a lot of resources to test that. But unless you can scale it like crazily, then maybe not sure. Maybe if you use lambda functions and like try to test on the mass scale, maybe you're gonna find it. But prototype pollution vulnerability, I think it's very rare, so I'm not sure if it's truly worth it to like spin thousands of servers just to search for prototype pollution. Not sure. Like, I have to actually do the work, do the dirt. All right. Okay, so let's close those tabs because my curiosity just sparked. I was just checking what's available there. So yeah, I guess for the next stream we could try like playing with some like practical stuff, because yeah, on this stream they found a lot of theory, like how it works from the ground up. It's kind of useful information just to understand, because if we can understand this vulnerability properly, then we can try maybe like play with little bit, create some automation, maybe try to play with labs, even like have broaden this knowledge. So yeah, so you can using constructor prototype can contaminate properties on prototype chain. So all of these methods need to be blocked together, ensure the safety. So yeah, for example, prototype pollution in Lodash merge is fixed using this approach. Special handling is done when key proto or prototype. So yeah, if you see this, but can it be bypassed by doing some I don't know, like before this, before setting the object, if you do plus symbols and insert variable here, would it be possible? I guess that could be bypass. I don't know, maybe, but I'm just throwing the ideas. I haven't tried it myself, but you will see. Maybe we can find a 0 day. This is like pretty interesting. The second method is simple and easy to understand, which is to avoid using objects, or more precisely, avoid using objects with prototypes. Some people may have seen a way to create objects like object create null. This can create empty object without proto property, a truly empty object with no methods. Because of this, there won't be any prototype pollution issues. Okay, so then you access the object with proto and then you pollute it. Or, oh no, cannot set property of undefined. All right, yeah. For example, the query string parsing library mentioned earlier, which is downloaded million times per week. Query string uses this approach for defense, as the documentation states. Another suggestion is to use map instead of this, but I think the most people are accustomed to using objects. Yeah, I guess developers, when developing code, don't think about prototype pollution. I guarantee. Like, some of them, not all of them, will know what is XSS, but prototype pollution, give me a break. Like, not too much of people. It is a bit more convenient than map. Yeah. Alternatively, you can use object freeze. Yeah, basically just continue on for like recommendations for developers. We can skip that, but real world examples. This is the good part, I think. Okay, finally, let's take a look at 2 real world examples of prototype pollution to give you a better understanding. Finally. The first example is a vulnerability reported by Vox to well-known bug bounty platform HackerOne in 2000. Okay, this is quite a while ago. Not quite a while ago as the XSS vulnerability arise, but still, like, compared to these days. Yes, it's vulnerability in the bug bounty platform itself. Okay, it was in the HackerOne itself. That's cool. The complete report could be found. Okay, there is a report. Can we read it? Because sometimes I see links and you cannot read. Okay. Oh, he scored only low. That's crazy. But still, he received some bounty. Uses to embed videos similar to this. What the hell is going on? Okay. Yeah, I'm gonna probably read this report a little bit later, but it's kind of interesting as well. Let's maybe read the blog itself. On the website, the third-party package is used, and inside the third-party package there is a piece of code that looks like this. And here we go again, the variables of letters. Okay, so it initializes the function, sets up empty variables, and if t equals, it parses the URL, and it parses document referrer. Okay, it parses the location href and document referrer, where the former is controlled by the attacker. Exactly. The function URL parse has a prototype pollution vulnerability. Okay. Oh, so I guess you can pollute the prototype via URL in this case. Yep. Like we've seen the examples in the payloads, all the things, how you can pollute the URL. and some nuclei template. That's kind of interesting. Allowing arbitrary. Okay, after the pollution, author discovered another piece of code that's similar to the create element we wrote earlier. From object, traverses properties and puts them on the DOM. By polluting inner HTML, an XSS vulnerability can be created using this script gadget. The actual attack involves constructing a URL that triggers prototype pollution plus XSS by sending the URL to someone, having them open it, then directly exposed to the attack. Another case is vulnerability in Kibana reported by Mikhail Betkovsky. The original code can be found here. Okay, let's see this one. RCE in Kibana. Okay, Kibana, nice. I think that I seen something similar on Bug Bounty Reports Explained. I think he has a video about prototype pollution. So I guess for the next stream we might want to explore if there is some kind of video. I also like reviewing video material. So if there is a short video, we can check that. Okay, this is really in-depth stuff. It's kind of crazy one. Okay. The official description of this vulnerability as follows. An attacker with access to the time-alone application could send requests which will attempt to execute the JavaScript code. This could possibly lead to an attacker executing arbitrary commands with permissions of the Kibana process on the host. Oh, so it's basically RCE. That's crazy vulnerability as well. Within Kibana, there is a feature called Timeleon, which allows users to input syntax and visualize it as charts. The following syntax can be used to pollute the prototype as props, so just using proto. Polluting the prototype is just the first step. The next step is to find script gadget. One of the code snippets in Kibana looks like this. The snippet retrieves environment variables which are used to run a new node process. For example, nv pairs is a equals 1. It will be execute command a1 node and custom JavaScript. Since it runs Node.js, we can secretly introduce a file using node options environment variable using require. Okay. Therefore, if we can upload a JavaScript file, we can execute the file in combination with prototype pollution. It sounds complicated. Is there another way? Yes. There is a commonly used technique where the content of certain files is controllable. For example, in PHP, the content of session file can be controlled. You can refer this article exploiting RC by introducing PHP session file via LFI. Well, this is kind of different topic, so let's skip it. Another example is file prot self environ in Linux systems, which contains all the environment variables of current process. Yeah, this is like if you can cat etc passwd, you will also want to cat this one out because it might contain some leaky stuff. Sure. If we can create environment variable called a console log blah blah blah, the content of this will become console log 123 yarn version blah blah blah. It becomes a valid JavaScript code. We can execute it using the method node options require this node bgs. The code provided by author is so it's just basically executing the reverse shell. This is the reverse shell. Okay, this is crazy. And then exiting. Okay, I like if this guy got 5-digit bounty, he truly deserved it. This is pretty interesting. Like all the exploit chain is very complicated, but it's hard work for sure. People like this truly deserve like good bounties. polluted two different properties, creating two environment variables, one to make this a valid JavaScript and include the code to be executed. On the other, node options to import this file through require flag, resulting in the RC vulnerability that allows the arbitrary code execution. If you are interested in Node.js gadgets, you can refer to this excellent paper. Okay, he's just throwing me with links. Like, I really hate when, for example, some, I don't know, like senior engineers or senior hackers, you ask them something and instead of like explaining in 2 sentences, we will just paste you the links and say, just read this or just Google yourself. I did this a couple of times as well, but come on, just say it. Like what you can do, why you cannot. Don't throw me articles like crazy. You are the guy writing articles. But yeah, okay. I guess having some references is good, but I would like more explanations then. Okay, invincible front-end gadgets. In fact, not only existing code in third-party libraries, but even some web APIs in browsers could be affected by prototype pollution. Oh, so this is like prototype pollution to universal XSS maybe? As usual, it's most useful to provide examples. Fetch example.com mode course. This is a simple piece of code that sends GET request, but if there is prototype pollution vulnerability like this, then it will change the method and the body. Okay, it transfers into the post request. Nice. This means that even these web APIs can be affected by prototype pollution, expanding the scope of the impact. This issue has been disclosed in Chromium bug. This behavior actually complies with the spec and does not require special handling. After all, the script gadgets like this will always exist, and the prototype chain is one of the JavaScript's characteristics. This is difficult to handle. It specifically deliberately ignores things on prototype chain when accessing properties. Therefore, the real solution is to start from the source and prevent the prototype chain from being polluted. And again, he's throwing a lot of articles instead of explaining. Okay, I guess that author of this article got tired at the end and started, okay, just fucking read it. Okay, conclusion. As mentioned earlier, not all attack techniques involve executing JavaScript directly. For example, the prototype pollution vulnerability may not seem significant at the first glance, just adding property to object prototype, so what? However, once combined with other code, it has a potential to disrupt existing execution flow and security assumptions, turning the seamless, harmless code into vulnerable code that could lead to XSS or even RC vulnerabilities. Yeah, so I guess there are some vulnerable libraries who can do the bad stuff for sure. Okay, some people even automate detection of prototype pollution vulnerabilities and identify problematic areas, taking prototype pollution to another level. Oh, a tale of making internet pollution free, exploit. Oh, I like automation stuff. I like it. Okay, this might be interesting read. Might be interesting. It's really in depth. Okay, maybe it's kind of could be good read. And the research team is really big. Number vulnerable. So basically they were reviewing libraries. As I said, you need to review libraries either by source code analysis tools or maybe just manually. The manual approach is the best for the most cases, but you have to understand JavaScript really well. Because when I've seen some examples from this guy just by using letters like this, it's kind of hard to read. I'm not used to that much to reading the JavaScript, but I know I should like focus more on that, but still. Okay, so some people even automate the detection, blah blah blah. In addition to research findings, it is also worth paying attention to the research teams behind it. They can be considered the all-stars of front-end security. Definitely, those guys are the best. The people who are like seriously doing some serious security research, those are the people, like, hats to them. When I first encountered this vulnerability, I had feeling a whole new world. Not a world, a new galaxy, as you said. The concept of prototypes that everyone is familiar in the front-end development have become common attack technique in the field of... I wouldn't say that's pretty common. Usually that's unknown field by many, but yeah, that's definitely pretty interesting topic for sure. How I did not know about this before. And it's not just prototype pollution, there are many other vulnerabilities that give me the same feeling. This is also one of the reasons why I wanted to write the series of articles, hoping the more front-end and JavaScript developer aware of different attack techniques. Yeah, so this was really good introduction for prototype pollution, but I think it's not enough. Even though I was just planning to read about prototype pollution and DOM clobbering, I guess I'm gonna spend one more stream just by exploring some other articles and maybe even trying some lab, or even like my own lab, or playing CTF by Portswigger. I'm also really interested what Portswigger is like, how they are explaining it, because their explanation and stuff are the best in the industry for sure. So I guess for the next week we're gonna continue for prototype pollution, and for today I guess that's gonna be it. So thank you guys for joining the stream, and see you on the next one.